So for finding mu, calculating mu, we're not going to really use the line of best fit. The solution when we solve for it is a little sloppy, so a little cumbersome. So we will use just we'll do a grinded out method. And the equation that we ran across when we did this earlier looked like, let's see if we can find it here. So here we are with friction, and here we go. It ends up being this monster, M1G minus M2G minus A times the total sum of the masses divided by M3G. So we're going to use that equation. We'll jump back, probably reference it in a minute, in here. But first, let's put our data in. So set your table up like this. If you need to pause the video to do so, feel free. But we're going to enter the data in. This is data that I just went through and got just a few moments ago. M1 is going to be, let's see, 1/2 kilogram for the first 3 trials. Then it was 0.7 kilograms for the next 3. And then it was 1, 2, 3, 4, 5, 6, 7, missing number 8. 8, 9. Missed a number in my data table. Thought this. Okay, so here. There we go. Alright. Then it's going to be 0.9 for 3 trials. Control D down. And then the last one's going to be 1.15 kilograms. And I'm going to format these to match the ones above them. So I'm going to highlight them, right click, go to Format Cells, Number, and let's go 3 decimal places like the others. There we go. Alright, mass 2 for every one of my trials was 0.333. Mass 3 varied, of course, that's going to be 0.130, and then 0.330 added to 200 grams, and then 0.530. And then that pattern repeats itself. So I'm going to highlight those, Control Copy, and then Control V to paste it, and then paste it again. And then down here was 0.130 again. Format this one to be like its buddies. Okay. Next, accelerations were 1.14, 0.6197, 0.239, 2.634, 1.908, 1.455, 3.662, 2.905, 2.328, and 4.889. Okay, and then I'm going to do this piecemeal. Instead of trying to do all of this in one big formula, in one cell, I'm going to simplify things a little bit. In fact, what I want to do here first is clarify. Actually, you know what we could do? No, we'll do it this way. So what I'm going to do here is point out that I could rewrite this. I'm going to try to do this with the mouse, so forgive me, but I'm going to factor out the G from these two terms. So I'm going to write G out here times M1 minus M2 end my parentheses, and then minus the A M1 plus M2 plus M3, and of course all of that over M3G. And the reason I did that is it's going to help me simplify when I put it into Excel here. I'm going to be able to use, really there's just a handful of values now. There's G, a couple places it shows up. There's the difference between M1 and M2 right here. There is this A, the acceleration. There's the sum of them all, and of course just M3 by itself. So if I go back to my workbook here, I'm just going to get M1 minus M2. So I hit equals, and M1 is this column, so I'm going to hit, for this row, I want to hit that minus M2, which is represented by this, and I hit enter. And to make it easy, I don't have to retype that, I just hit Control down. I highlight that, and if you need to, by the way, I think we can, I can't remember how to fill, I think fill down will do it as well. So if you don't want to do the shortcuts on the screen, you can go fill and down, boom. No surprise, it's for the first three it's the same, next three it's and so forth and so on, because M1 and M2 are the same now. We're going to do the sum of all the masses here. We're going to use that function. We're going to hit equals, and we're going to type sum, and then a parenthesis, and now we're into that function, and we're going to add up all three of those. So I highlight all three like that, close my parentheses, hit enter, and then we're going to control down. Fill down. There we go. These little triangles are they're asking, hey, by the way, there was a number here and there was a number here and you didn't include it in your sum. Are you sure you didn't miss anything? We know exactly what we want, so we're okay. We can ignore their little, hey, did you make a mistake thing. Of course, G, we're going to use 9.8 in this case. We're going to assume that we know it. Fill it out, and then we'll also fill down. And then muck, or mu kinetic, as a matter of fact, we're going to now put together that whole formula that we looked at. So if we go back and we look at it real quick, it's going to be G times M1 minus M2. That's the first part. So equals. Now I'm going to put a set of parentheses here. Look, I'll put it over here and I'll show you. I'm going to put a set of parentheses around the entire numerator. Boom. And when I get down there, I'll probably even definitely put a set of parentheses around the entire denominator as well when I put it into Excel. So equals, and I'm going to do a parenthesis. That's going to start the numerator, and it's going to be G, this guy, times M1 minus M2, this right here. You know, I'm going to use another set of parentheses. I tend to overuse parentheses. If I want to insert one now, I go here. I gotta be careful. Let me start that over because I think I might have shifted over there a little bit. So equals, and we're going to go parentheses, double parentheses here. So we're going to go G times M1, M2, boom, parentheses, minus, let's go look at our formula, A times the total sum, minus A, which is this one. You know what? Parentheses there. A times the total sum, which I did in this block here. Then that ends the numerator. So there's my numerator. Divided by, put a parenthesis, I want M3, this guy, boom, times G, this guy, I can't see it. All right, I can do this. If I can't click on it because this is in the way, I know it's H5, so I can just type H5, taken care of, and I put parentheses around it. That's the denominator, and I should be good. And then I highlight it and go down. I hit fill down. Right. Now, interesting array of values here. I'll take the average of those. So I type in the average function, equals, and then the average, and then a parenthesis. And I know I'm in a function because I see this little thing here. And I can just highlight all those, click and drag, end my parenthesis, hit enter, and there's my average. And then to get an idea of the spread of the data, how crazy the data is, I'll do standard deviation. Whoops, ST, there it goes. Last video I did population. I'm gonna check both out here real quick. So standard deviation population gives me, I'm curious which one. Boom. And then right here I'm gonna do equals standard deviation of sample. Mr. Sable or some other statistics person would probably tell me which one is better. I should probably know, but I like this one a little better because it's smaller. So I'm going to get rid of this one, little error as I possibly can. And so that gives me a range of values for mu that would go from, let's see, the low value would be the average minus the standard deviation. And the high value would be equal to the average plus one standard deviation. So it's between 0.20. So actually, it's fairly good. We're right in there at 0.3. Should be right around the middle anyway. Now, unlike G, I don't have anything to compare this to. What we're going to do is, by the way, if you're wondering, this was the wooden box, not all wooden box, no plastic on top. Wooden box on wooden track, of course. Everybody had the same track. So my coefficient would have been about 0.3 or so. You can, if you happen to have that same thing, you can check to see if yours came out to be the same. We'll compare notes among groups and see how everybody got, what everybody got. And in addition, we're going to do this. We're going to find mu a different way later on. Not that long from now, actually, using inclined planes, and that will also give us an idea of where we are with this number, how reliable it is. All right, that's it.